Graphing absolute value functions. An absolute value is an equation whose graph either looks like a V or an upside down V. So what I mean by that is if we have a graph, this is our X, this is our Y, and an absolute value function is going to go down, kind of like a line, and then it's going to stop at a point, and then it's going to come back up. And then they're going to have arrows going up like that. So it's going to look like a V, or there's the possibility that it goes the other direction. There's my X, there's my Y. We could kind of go down, and then go up, and then go back down. But the point is, it's not always going to go in a straight line. It's going to go in a straight line for a while, and then it's going to turn around and go back down. Those are absolute value functions. Now, the absolute value parent function is y equals negative absolute value of x. That's what we call the parent function. And when we graph the parent function, it is always going to go up 1 over 1 from the origin, from the 0, 0 point, and then it's going to go up 1, back 1. So these two are going to be exactly the same, and they're going to meet right there at the point 0, 0. So that's my parent function. Now, when graphing an absolute value function, we just move this parent function around in order to get our final graph. Or you can just put the numbers into a table and plot the points. We've already done that, so we're not going to work on that. We're going to work on just shifting this entire V around. Alright, now we're going to do some examples of understanding how graphs move and how to graph them. The first thing we want to note is we're doing something to the graph. We start with our parent graph, which is going to start at 0, 0, and it's going to go up 1 over 1, up 1 over 1 repeatedly, and then it's going to be a V, so it's going to be the same on the other side. So be careful when you are doing these, and make sure you plot your points to make them straight lines. Okay, so now I'm going to move this graph. How am I going to move this? To do this, we want to note a few things. First thing, in this instance, if the minus sign is inside with the absolute value of x, then we're going to move right. So we see the minus sign is inside the absolute value with the x. So I'm going to move to the right. So I'm going to take every point and move it to the right 2 spots. 1, 2. So that's going to become the point of my V. And then everything else is going to move over, so my V is just going to look like that. Move 2 spots over. So this is my final. This first one I drew as my parent function. And you should draw both so that you can easily move them like that. So what you're going to say is you have to graph it and then tell me translation to the right. And that tells me how it moves. On this next one, I again started with my parent function there. And I'm going to do something to it. So I have the equation y equals the absolute value of x plus 2. Now this time, the symbol is not inside the absolute value, so we have to have another rule. If there is a plus on the outside of the absolute value of x, then you're going to move up. So the plus is on the outside of the absolute value. So I'm going to move up. So up, because it's a 2, I'm going to move up 2, 1, 2, and then my point of my V is going to be there, and then I move everything else up 2, go up 1 over 1, and then I go backwards. So this would be my final. my final graph, and then I need to explain what that means. It's a translation up 2. So you have to graph it and tell me how it moves. In this next one, again, I have my parent function graphed there, and I want to look at y equals the absolute value of x plus 2, and all of that is inside the absolute value. Okay, well, before I had a minus inside the absolute value. This time I have a plus, so I have to have another rule. So the next rule is if it is a plus on the inside of the absolute value of x, then you're going to move to the left that amount. So we have plus 2 on the inside of the absolute value, so we're going to move to the left 2 spots, 1, 2. So that is the new point of my v, and then I'm going to go up 1 over 1, and there's part of it, and then I go up 1 over 1 the other direction. There's the other part, so this is my final graph. Okay, now if I were to describe that, I would say it is a translation of 2 units to the left. And that would be your description of how it is moving. It's moving 2 units to the left, and we graphed it. For this next graph, we have y equals the absolute value of x minus 2. Alright, so again, we now have a minus 2 on the outside, so we need yet another rule because last time it was plus 2. So if there's a minus on the outside of the x, then what we are going to do is move down however many units. So there's a minus 2 on the outside of the absolute value. So we're going to move down. And we're going to move down that number of units, so down 1, 2. So that is the point of my v, and then I'm going to go up 1 over 1. So this is my final. And what did I do? Describe your movement. It is a translation 2 units down. And that would be your description, and you're done. It's also possible that we might do more than one thing to it. Okay, so right now we actually have negative absolute value of x plus 2. The plus 2 is inside with the absolute value, so we know we have to move left. Plus on the inside means we have to move left. However, we also have a negative sign. If it's attached out front like that, it means it's a negative sign. We have a negative sign. We didn't discuss what a negative sign means. Negative sign means we're going to flip it over. And if it's a negative on the outside, of the absolute value of x, like we have, then we're going to flip over the x-axis. Alright, so we're going to move to the left 2 from the plus 2, and then we're going to flip it over the x-axis. Alright, so the first thing, I'm going to draw it flipped over the x-axis. So this part right here is going to, my v is going to stay in the same spot. Recall that this is my x-axis, so instead of going up, it's going to go down like this. And down like this. So now I have that pink graph. That's after my reflection. And the next thing I'm going to do is my plus 2. So that is moving left 2. So this is my new point, and remember, it's the pink graph we're changing now. So this is my final. My final graph is an upside down V that has been shifted to the left 2. So if I'm going to write out what that means, I'm going to reflect over the x-axis and translate left 2. So that would be your description on this one. Definitely a little bit more difficult. So for this last one, we have our parent function graphed already, and we are looking to graph y equals the absolute value of x minus 3, all under the absolute value, plus 1. Okay, so the minus 3 is inside, so we have a minus on the inside, which is going to tell us it goes right 3 units. And then we have the plus 1 on the outside. So that's going to tell me it goes up 1. So now I'm going to graph these, and I'm going to graph it in stages. So we're going to go the 3 to the right, 1, 2, 3. And so my new V point is going to be there. So that is after I move right. And then I'm going to move up 1. So I'm moving the point of my V up to there, and then I'm going to draw my V. So this is my final. So you should draw it in stages so that you don't get it confused. So that is my final translation, and then I have to describe it. So what did I do? I translated three units to the right, and 1 unit up. So that would be your description of what you did. Final answer. Those are your notes over graphing absolute value functions and understanding how to translate them. Go through your practice problems, make sure you can do these different things, and you can remember how things move when the equation looks a certain way, and then you should be ready for your quiz.